All right, here's a good question. It deals with Dalton's law of partial pressures, in that a gas acts independently of the others, and the sum of the pressures of each of those gases give you the total combined pressure. So this question says I've got 5 moles of oxygen, 2 moles of helium, 3 moles of chlorine. And they say they exert a total pressure of 500 millimeters of mercury. And so what is the partial pressure of each gas? Well, they don't tell us. Like, I'd like to go off with my PV equals nRT, and P is equal to nRT over V. Tell me how many moles, which I have, and I know the gas constant, but I don't know a temperature and a volume. And so I'd like to use that formula, but I don't have any of that other information. But I do have Dalton's law of partial pressures. So the pressure total is equal to the pressure for this one of oxygen, plus the pressure of helium, plus the pressure due to chlorine. So if they tell me that the total pressure is 500, then if I add these pressures up, they have to come out to 500. We know that moles and pressure, there is a relationship between those. So what I can do here is I can just add up how many moles I have. So I've got 5 plus 2, 7 plus 3 is 10. So I have 10 moles total. So if I have 10 moles total, oxygen has 5 of those 10, right? So really 5/10, that's like 50%. Oxygen will be contributing to the pressure of the total container to a degree of 50%. So if the total pressure is 500 millimeters of mercury, oxygen's got to be given half of that, or 5/10 of that. So oxygen is going to be half of 500, so it'll be 250 millimeters of mercury. And what I can do is, if I want to calculate that, like if the numbers aren't that good that I can do them in my head, I can just take this ratio of oxygen and multiply it by the total pressure. So if you do that, 5 times 500 divided by 10 is going to give you 250. So if I look at helium, it's given 2 moles out of the 10. So 2 times 500 is 1,000 divided by 10 would be 100. So helium, it is given us 100 of the pressure. And then chlorine, we can figure that out. That would be, 150? Let's use our ratio, though. So chlorine, it's given 3 out of the 10 times the total pressure. So 3 times 500, 1,500 divided by 10, sure enough, 150. So the pressure due to chlorine, that chlorine is contributing to that vessel, will be 150. Okay, that's a nice Dalton's law of partial pressure question.